A rig is complicated, but easier to understand if divided into related parts. In this section, we will cover the equipment used in hoisting. Hoisting equipment hangs or suspends the drill string in the hole. It also allows the driller to raise and lower the drill string into and out of the hole. Further, it allows the driller to adjust the weight on the bit, which is required to make the bit drill. The equipment used in hoisting is shown here. The crown block, the traveling block and hook, the drilling line, the drilling line supply reel, the deadline to crown block, the fast line to drawworks, the drawworks, and the deadline anchor. Here's an overview of how the hoisting system operates. The supply reel stores drilling line. To reeve the line, crew members start at the deadline anchor. They pull the line from the supply reel and spool it around the disc on the anchor. They then lift the line to the top of the mast, to the crown block. Crew members then reeve the line several times between the crown block sheaves and the traveling block sheaves. The number of times depends on how much weight the system needs to lift. In this case, they ran the line 5 times between the 2 blocks to create 10 lines. Once they've strung the right number of lines, they run the line to the drawworks and firmly clamp the line to the drum. The driller then takes in the drilling line, which wraps around the drum. The driller usually takes in enough line so that the line makes at least 6 wraps around the drum. They then clamp the line at the deadline anchor. As the driller activates the drawworks to take in line, the traveling block moves up. The driller uses the brake to stop the traveling block at any position. The rig builder mounts the crown block at the top of the mast. The crown block has several pulleys, called sheaves. The block manufacturer mounts the sheaves side by side on a shaft. The drilling line runs over the grooves in the sheaves. Sometimes, like this one, the crown block has a special fast sheave. The drilling line runs over the fast sheave as it leaves or enters the side-by-side sheaves on the crown block. Crown blocks have load ratings that range from about 420 to 1,400 tons, about 380 to 1,300 metric tons. Sheave diameters range from 42 to 72 inches, or about 107 to 180 centimeters. A traveling block also has several side-by-side sheaves. A steel housing encloses them. Crew members thread or reeve the drilling line over the sheaves. A hook is attached at the bottom of the traveling block. The hook suspends the swivel, kelly, and drill string, or a top drive and drill string. This is a traveling block on an offshore floating rig. It has a drill string motion compensator. The motion compensator is between the traveling block and the hook. Offshore floating rigs move up and down with sea movements. The motion compensator maintains drill string position by counteracting up and down vessel movement or heave. On some semi-submersibles and drill ships, rig owners mount the motion compensator on the crown or the top of the derrick. The compensator eliminates the motion of the drill string from the hook to the bit. As the vessel moves up and down, hydraulic pressure inside a piston and cylinder keep the hook in a fixed position relative to the seafloor. The compensator keeps the drill bit on the bottom of the hole, within the weight-on-bit limits set by the driller. A typical compensator can compensate for up and down movement as much as 15 to 25 feet, 4.5 to 7.5 meters. Typically, two sizes of motion compensator are available. One can handle loads up to 400,000 pounds, or about 180,000 kilograms. Another one, which is bigger, can handle loads up to 600,000 pounds, or about 270,000 kilograms. Some traveling blocks have built-in hooks. They are a single integrated unit. The combination hook block is shorter and therefore allows more traveling distance when mast height is limited. Typical combination hook blocks have load ratings ranging from 175 tons to 650 tons, about 160 to 590 metric tons. Some traveling blocks and hooks are separate units. In this type, the bail of the hook fits into a clevis on the bottom of the traveling block. Crew members suspend the swivel and drill string from the hook. They open the hook's latch, insert the swivel's bail, and close the hook's latch. A safety catch ensures that the hook stays latched. Separate traveling blocks are available in load ranges from 100 to 1,250 tons, or about 90 to 1,125 metric tons. Sheave diameters range from 24 to 72 inches. 61 to 183 centimeters. That's 2 to 6 feet, or over half a meter to nearly 2 meters in diameters. Hooks have load ratings of from 350 to 1,000 tons, about 300 to 900 metric tons. The hook has two link ears. The crew attaches one-piece forged links and an elevator to the ears. They lock the links to the ears with the link locking arms. Crew members latch the elevator to tubulars, joints of drill pipe and other types of pipe, as they run them into and out of the hole. Crew members latch the elevator around the top joint of the drill pipe. Then, when the driller takes in drilling line, the traveling block goes up, raising the elevator and attached pipe. Conversely, when the driller lowers the traveling block, the elevator and attached pipe also go down. Crew members use many types of elevators. Which one depends on the kind and size of the tubulars. For example, most drill pipe and lifting subs require a center latch bottleneck elevator. But some drill collars require a side door collar type elevator. Tubing, a lightweight pipe used in completing wells, usually needs a slip type tubing elevator. Casing, large pipe the crew lines the hole with, requires a special heavy-weight casing elevator. The two types here are the single-joint casing pickup type and the 500-ton or 450 metric ton casing elevator spider. Most hooks have two locks: a rotation lock and an automatic positioner lock. Crew members use a long steel rod called a shepherd stick or a chicken hook to unlock and lock the rotation lock and the automatic hook positioner. When crew members unlock the rotation lock, they rotate the hook to make the elevator face in the desired direction. Once positioned, they lock the rotation lock to keep the hook in position. Crew members can also release the rotation lock when the hook needs to rotate freely. The other lock, an optional automatic hook positioner, prevents rotation of the elevator links when the hook is traveling empty. Normally, just before making a trip encased hole, crew members unlock the rotation lock, turn the hook, and relock it so that the elevator faces the derrickman. This makes it easy for him to latch and unlatch the elevator. If crew members are tripping pipe in open hole, they activate the automatic hook positioner. This lets the hook rotate freely when hoisting the drill string. Allowing the drill string to turn an open hole as it is being pulled keeps it from damaging the hole and prevents the reeved drilling line from twisting. Then, when the elevator reaches the derrickman and the driller stops hoisting, the positioner automatically rotates the elevator into correct position for the derrickman. Inside the hook is a hydraulic snubber. The snubber is like a shock absorber. It prevents drill pipe bounce and tool joint damage when spinning out the connection. Drilling line is high-strength, heavy-duty wire rope. The manufacturer braids several wires together to form the rope. Drilling line comes in diameters ranging from 7/8 of an inch to 2 inches, about 22 to 51 millimeters. Crew members string or reeve drilling line between the crown block and the traveling block. The more lines they reeve, the more weight the system can support. Here, for example, they reeve the line 5 times between the blocks, so that 10 lines support the traveling block. Here's the crown block and traveling block strung together by drilling line. Note how the traveling block goes up and down as the driller takes in or lets out drilling line. The dead line is drilling line that runs to the dead line anchor. The fast line is drilling line that runs to the drawworks. Notice the 5 wraps of drilling line between the crown and the traveling block. 5 wraps makes for 10 lines. 10 lines can lift 10 times the weight of a single line. Also notice that the crown block has one more sheave than the traveling block. This extra sheave is for the fast line. Drilling line comes to the rig on a large supply reel. Normally, crew members string the needed amount of line through the traveling and crown blocks and onto the drawworks. Then, they keep the extra line on this supply reel. The reason they keep the extra line is for a slip and cut program. As the driller raises and lowers the traveling block and its associated loads, the drilling line wears. It tends to wear more where it passes over the traveling block sheaves and the crown block sheaves. The line has to bend around the sheaves, and this puts extra stress on it. The line also wears more where it reaches the end of the drawworks drum. It has to reverse direction here and start back the other way on the drum. This direction change puts extra stress on the line. To distribute the wear on the drilling line, the crew slips the line a predetermined amount. Slipping the line moves the wear points on the line. To slip the line, crew members lower the traveling block to the rig floor. They then rig up a special hang line from the crown beam to the top of the traveling block. The hang line keeps the block from moving. With the block unable to move, they unclamp the drilling line at the deadline anchor. The driller then uses the drawworks to pull new line off the supply reel. The line slips through the deadline anchor and stationary traveling block. The worn line reels onto the drawworks drum. To keep too much line from accumulating on the drum, crew members cut off the end of the worn fast line and discard it. This is the deadline anchor. It firmly secures the drilling line and keeps it from moving. Drilling line comes off the supply reel and loops several times around the anchor. The rig crew then firmly clamps the line to the anchor. The line leaves the anchor, goes through the crown and traveling blocks, and then to the drawworks. Clamping the deadline to the deadline anchor mechanically isolates the drilling line from the supply reel. Because the line is stationary, it is called the deadline. The drawworks has a large spool or drum around which the crew members wrap the drilling line. Power from the engines or electric motors drive the drawworks drum. When the driller activates a control and releases the brake, the drum reels in drilling line. Reeling in drilling line raises the traveling block and whatever is attached to it. To lower the traveling block, the driller releases the drawworks brake. The force of gravity pulls the block down. The driller controls the descent by applying the brake to slow or stop the downward travel. The smallest drawworks are around 550 horsepower, while the largest have 4,000 horsepower, about 400 to 3,000 kilowatts. Small drawworks can handle wells drilled to around 3,000 feet, 1,000 meters deep. The largest can handle 40,000 foot or 12,000 meter depths. When the driller moves the brake handle down, the drawworks brake bands exert friction on both rims of the drum. We're only showing one rim to keep it simple. This friction slows or stops the drum. When the driller lifts the brake handle a small amount, tension on the bands eases. With tension eased, the drawworks drum rotates a small amount to gradually lower the load. When the driller lifts the handle up fully, the bands do not touch the drum rims at all. The drum rotates freely, and the load drops in free fall. Many new drawworks use a disc brake system. Disc brakes are more efficient than drum brakes. A typical disc brake system consists of three major components. Two discs, one on each end of the drum. A hydraulic operating system, which you can't see here. And caliper and pad assemblies. The system has 6 service calipers, 3 on each disc, and 2 emergency calipers, 1 on each disc. When the driller engages the brake, hydraulic pressure pushes in the pads inside each service caliper. The pads contact the disc and slow or stop the drum. If hydraulic pressure fails, the emergency calipers set automatically. Mounted on the end of the drawworks drum shaft is an electrodynamic brake. It is an auxiliary brake that uses powerful electromagnets. The electromagnetic force works against the turning force of the drawworks drum shaft. It assists the mechanical drum or disc brake you just saw. It controls the speed of the load as it goes down. The driller cannot control the load speed with the drum or disc brake alone. The weight of the load, plus the tremendous inertia it creates when moving, is just too great. So, the driller activates the electrodynamic brake. The electrodynamic brake provides most of the braking force when the drawworks drum is turning. The most modern drawworks braking system does not use an electrodynamic brake. Instead, the drawworks is powered by a special computerized motor and control system. The computer control system allows the drive motor to power the drawworks and provide the auxiliary braking force. Mounted on the drawworks, near the drawworks drum, is a crown saver, or a crown-o-matic, a brand name. A crown saver keeps the driller from accidentally raising the traveling block into the crown block. It has a probe that activates an air-actuated toggle switch if the driller takes in too much drilling line onto the drawworks drum. Too much line indicates that the driller has raised the traveling block too high in the mast. If he raised the block any more, it would crash into the crown block or separate the rotary hose, causing a lot of damage. Too much line on the drum activates the toggle switch. The switch then immediately engages the drawworks brake and disengages the drawworks clutch. Clutch disengagement disconnects the drawworks drum from its power source. The latest drawworks use an electrically actuated crown saver system, but still maintains the pneumatic crown saver as backup. To make the bit drill. The equipment used in hoisting is shown here. The crown block, the traveling block and hook, the drilling line, the drilling line supply reel, the deadline to crown block, the fast line to drawworks, the drawworks,